Okay, engineers, let's do one example from the homework. I don't remember which is the number of this problem in the homework, but let's solve it. For this, you have a combination of real root and imaginary root. The roots is s equal to 2, and for this is a complex number or imaginary number. Alright? So the partial fractions on this case is going to be a over s minus 2 for this root, and then bs plus c over this for this, which is imaginary root. Remember, the rules is that for real roots you are going to use this type of partial fractions, or for imaginary roots we are going to use this type of partial fractions. Okay, now let's use the Heaviside method to find the values of a, b, and c. Let's do it for the easiest, which is the value of a. To find the value of a, what you are going to do is to consider this fraction, but without the s minus 2, which is the number of this. So it's going to be 3s plus 2 divided by s squared plus 2s plus 5 only, and then you replace the value of the root, s equal to 2. Okay, so if you do so, then replace the value. Here is going to be 6 plus 2 over, here is going to be 4 plus 4 plus 5. So the result of this is 8 over, this number is going to be 13. Alright, so that is the value of a. So you have found the value of a, this partial fraction. Okay, now for the other, let's use the same Heaviside method, but here you have to replace the value of the imaginary root. So be careful on this, because you are going to deal with complex operations. So bs plus c is going to be equal to, is going to be 3s plus 2, and for that you are going to eliminate this part of the fraction, which corresponds to this. So the only thing left is s minus 2, and then you are going to make the replacement in s equal to minus 1 plus 2i. You can choose either 1 plus or minus, it's the same, it doesn't change the results. Okay, let's do the replacement. So what you are going to have here is b times minus 1 plus 2i plus the constant. That's on the left side. On the right side you will have minus 1 plus 2i plus 2. 3 times the complex number, the imaginary root, and then minus 1 plus 2i, and then minus 2. Okay, on the left side, let's separate the real part and the imaginary part. So the real part is going to be c minus b for this, c minus b, and then plus 2bi. So this is the real, and this is the imaginary part. On the right, what you have is minus 3 plus 2 is going to be minus 1 plus 6i, because this 3 multiplies also this, and then in the denominator you are going to have minus 1 and minus 2, minus 3 plus 2i. Okay, so what we have to do is to make equal this complex number equal to this complex number, but here is in a fraction. So what we have to do is to eliminate the fraction. The way to eliminate the fraction is by making the multiplication times the conjugate. The conjugate of what? Of the denominator. Minus 3 minus 2i. If you do the division, you have to do the multiplication to compensate. Minus 3 minus 2i. Okay? The conjugate is just opposite of this sign. Okay, so let's do the multiplication. And here is where you have to be very careful, because you are going to deal with multiplication of complex numbers. Okay, so let's do it. So this equal is minus 1 times minus 3, 3 positive, and then plus 2i, and then minus 18i, and then minus 12i squared. Remember that the I squared becomes minus 1. In the denominator is going to be, because it's a difference binomial, difference squared, is going to be root 9 minus 4i squared. Okay, because this I squared is also minus 1, then the minus 4 is going to become plus. Okay, so what is the result of this? The result of this is in the denominator is going to be the 13 positive. In the numerator is going to be minus 12 times minus positive, so this is going to become 15 in the real part, and then minus 16 imaginary part. Okay, so what you have on the left is c minus b plus 2bi imaginary root, and then on the right what you have is 15 over 13 minus 16 over 13 imaginary number. Okay, so what you have to do is make equal the real part and the imaginary part. So that means that this number and this number must be the same, and this number and this number must be the same. So 2b is equal to minus 16 over 13. So that means that b is equal to minus 8 over 13. So that is the result of b. Okay, so now the value of c. C minus the value of b, minus 8 over 13, equal to 15 over 13. All right. Okay, so what is the value of c? This becomes positive, but to the other side is going to be negative. 15 minus 8 is going to become 7. All right. 7 over 13. Okay, so what you have found is the values of a, b, and c. So the partial fractions will be something like this. The value of a happens to be 8 over 13. I'm going to write it outside. 8 over 13, 1 over s minus 2. Alright? And then the value of b. B is going to be minus 8 over 13 s plus the value of c, 7 over 13, divided by s squared plus 2s plus 5. If we are going to calculate the Laplace inverse, then we are going to make the calculation of this. Instead of making the Laplace inverse of this, we are going to do the Laplace inverse of this. So as you can see here, this is very easy, it's the exponential, but this one is not easy to see. Okay, so it's going to be 8 over 13, the Laplace inverse of 1 over s minus 2, and then from here we can factorize the 1 over 13 because it's the same number, and I'm going to also factorize the minus 1 over 13, the Laplace inverse of 8s minus 7 because we factorize the minus, remember here, over s squared plus 2s plus 5. Now this fraction we have already solved it in the previous video where we complete the binomial and then we apply the formulas of the exponential times the sine and the cosine. So we have already solved this, so just replace the result. So the result is 8 over 13 exponential of 2t from here, and then minus the result of that was 8 over 13 exponential minus t cosine of 2t minus 15 over 26 because 1 over 13 exponential of minus t sine of 2t. Now how do I get from here to here? Just check the previous video where we solved this Laplace inverse. Alright, engineers? So this is the way to solve this kind of partial fractions where you have real and imaginary, and this imaginary root is a complex like this, and you have to apply to complete the binomial and so on. Okay, engineers, next video we are going to solve a differential equation. Alright, and see you in the next one.